So we have one more example to do with this rotation stuff, and this is about as tricky as it gets. But on this last example here, I want to rotate the triangle SAM, or SAM, 270 degrees. That's a positive angle, so we're going to go counterclockwise about the point 4, -2. So this one doesn't actually rotate around the origin, it rotates around 4, -2, this point right here. So here's my recommendation for doing problems like this. I would just pretend that that's the origin. Just draw out a new pretend y-axis and x-axis that go straight through that point, and just pretend that that's the origin. And then just work it out as you did that other problem. So if I want to go 270 degrees, that is a counterclockwise rotation because it's positive. Normal clocks go this way, so counterclockwise is that way. So basically we're going to go this way 270 degrees. So 1, 2, 3 sets of 90s and land there. If we want to make this a little simpler, positive 270 is the same thing as negative 90 degrees. So why don't we just think about that instead? I'm going to go clockwise 90 degrees that way. It's helpful for me to just think of one turn rather than 3. Basically, A and M are going to land in that quadrant there. Remember, I'm pretending this is the new axis. And S is going to land in that quadrant. It can be kind of hard to figure out where exactly the points go. So again, I'm going to do the whole like rotate your paper trick. So if I have point S and I rotate 90 degrees clockwise, and now pretend that this is the y-axis, and pretend that that's the x-axis, and S is supposed to land at -1, -2, -3, 1, 2, 3, 4, 5, 6, 7. S is now at -3, 7. So rotate back. Again, use this as the origin. Go to -3, 1, 2, 3, 4, 5, 6, 7. And there's my new S prime. I'll do the same thing for these other 2 points. So if I rotate it -90, rotate one turn, M is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So 4, 7. So I'll go to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And that's good because those should be lined up. So it makes sense that they'd be on the same line here. So there's M prime. And to get to A, I just go over 1, up 2. So I'm going to go over 1, up 2. And there's A prime. And that is my full rotated shape. I do want to show you one way you can check your work on these is if it was a 90-degree rotation, then you should be going 90 degrees. Like if I were to connect point M to the center of rotation and M prime to the center of rotation, it should form a right angle because I rotated it 90 degrees. Same thing with the other points. If I were to connect S prime and S, that should also form a 90-degree angle because I rotated it 90 degrees. You can even use that to help you work on these problems. Like you could think about this right here as being over 1, 2, 3, 4, 5, 6, 7, and up, down 1, 2, 3. And if you were to rotate that triangle, it would be 7 and 3, and that would give you that point there. Remember, that's not actually the origin, so we can stop pretending now. We can erase this point, erase those pretend axes, and now I can go back to this being the actual origin, and that's my rotated shape, but I rotated around this point. Just to wrap up this transformation stuff, occasionally we write these transformations as functions. So for example, if I turned the point xy into x plus 1 and y minus 2, that would be like let's say I had the point 4, 5, and I want to see what this is going to do to it. So the point 4, 5 is right here. If I take 4 and I add 1, so that would be 4 plus 1, and then it would be 5, and for y, minus 2, which is going to give me 5, 3. So it turned into 5, 3. Basically, you could just plug in the point in for x and y and see what you get out, just like a normal function. This transformation is a translation, a slide, because you basically shifted everything right 1 and down 2. If I wanted a rule to describe this, going from this triangle here to this triangle here, I notice that I go up 1, 2, 3, 4, and so the rule would be to take the point xy. The x values aren't changing at all. All that's happening is it's shifting up 4. And so x stays the same, but y, we're going to add 4 to it. We're shifting everything up 4. Or like on this one, it might be kind of helpful to list out the points. This one went from -1, 0 to the point 0, 1. It also went from -1, -1 to 1, 1. And b actually stayed in the same place. It went from 1, 2, 3, -1, 2, 3. So from 3, 3, 3, -3 to 3, -3. So what's happening here? I can see pretty clearly on this one that the x and the y are switching places, and it looks like they are changing signs as well, because this went from -1, -1 to +1, +1. So the way we would represent this is you would take some generic point, x, y, and transform it by first of all switching x and y, flip the order, and then also make them negative. Let's make sure that worked. If I took 3, -3, and I flipped them, it would become -3, 3. And then if I made them negative, it would become positive, negative, which is what we got for that other point. Or if I took -1, 0, and they changed order, it would be 0, -1, and then make them both negative, I would get 0, +1. So that does work.